Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn the model matrix and diagonalization of the matrix, given matrix. How to simplify? Let us see step by step. First, represent the given matrix, that is given A, which is equal to 5, 3, 1, 3. To find the first, we need to find the model matrix. To find the model matrix, we need to represent the eigenvalues, eigenvectors. Whatever we get the values of eigenvectors, if we represent this eigenvectors with respect to matrix, that matrix we call it as model matrix. So let us find the first eigenvalues. So find the eigenvalues. The characteristic equation is given by characteristic equation is given by determinant of a minus lambda I equal to 0. That is determinant of a minus lambda I, which is equal to determinant of 5 minus lambda 3 1 3 minus lambda. Okay, just multiply 5 minus lambda into 3 minus lambda minus 3 into 1, which is equal to 0. 5 3s are 15. Next, minus 5 lambda minus 3 lambda plus lambda square minus 3, which is equal to 0. Now represent this in the equation form. Lambda square minus 5 lambda minus 3 lambda, we have minus 8 lambda. 15 minus 3 plus 12, which is equal to 0. Now factorize these terms, that is 12 lambda square. If you factorize, we are going to get we need to get 6 2s are 12, or 2 6 are 12, 6 2 lambda, see, minus into minus plus 6 2 6 are 12, lambda into lambda square, that is lambda square minus 2 lambda minus 6 lambda plus 12 equal to 0. Take the common, represent it in the equation form. Lambda into lambda minus 2 minus 6 into lambda minus 2 equal to 0, where lambda minus 2 into lambda minus 6 equal to 0 is the characteristic equation of the given matrix then therefore the roots lambda 1 equal to 2, lambda 2 equal to minus 6 is the eigen values of the given matrix of the given matrix. Now, considering these eigenvalues, we are going to find the corresponding eigenvector. That is, consider A minus matrix A minus lambda I into X, which is equal to 0. What does X represent? The number of unknowns. That is, what is A minus lambda I? 5 minus lambda 3 1 3 minus lambda into x y equal to 0 0. Then consider this as equation number 1. Now case number 1, what is our case number 1? Lambda equal to lambda 1 equal to, what is the root? First root is 2. In equation number 1, what we are going to get, that is A minus lambda I into x1, which is equal to 0. What is A minus lambda 1? That is 5 minus 2 3 1 3 minus 2 into x y which is equal to 0, 0. Now just simplify 5 minus 3, sorry, 5 minus 2, 3, 3, 1, 1 into x, y equal to 0, 0. Done. See, first row and second row are same, because if I divide first row with respect to 3, again you are going to get 1, 1, 1, 1. Either consider any one row and represent this in with respect to linear equation form. That is, let us go with the first equation itself. 3x plus 3y equal to 0. Now I need to consider the unknowns x, y, so that LHS should be equal to RHS. So what I am going to consider, x is equal to 1 and y equal to minus 1. Then LHS will be equal to RHS. If I simplify 1, 3, 3 into 1, 3, 3 into minus 1, minus 3, plus 3 minus 3 get cancelled, we get 0. Then the unknown x1, which is equal to xy. What is the value of xy? We are going to consider 1 minus 1 is the eigenvector corresponding to eigenvalue when lambda equal to lambda 1 equal to 2. Done. First case, that is lambda equal to lambda 1 equal to 2, is we have found. Next, let us find case 2. What is our case 2? Case 2 is our lambda equal to lambda 2 equal to, the root is, oh sorry, plus 6, not minus 6, plus 6, which is equal to 6 in equation number 1. Now, that is, what is our equation number 1? A minus lambda I into x2, which is equal to 0. That is 5 minus 6, 3, 1, 3 minus 6 into x2 is x, y, which is equal to 0, 0. Now, let us simplify. That is 5 minus 6 minus 1, next 3, 1 minus 3 into x, y, which is equal to 0, 0. Done. Now see, first row is also same, second row is also same. Represent this in the linear equation form, that is minus x plus 3y equal to 0. Choose or consider the x and y so that LHS should be equal to RHS. So what I am going to consider, x equal to minus 3, sorry, just x equal to, just consider 3 and y equal to 1. Then LHS will be equal to RHS. If you need, you can check. Minus 3 plus 3 into 1. That is, minus 3 plus 3 get cancelled. The solution will be equal to 0. Now, represent this with respect to eigenvector, that is x2, which is equal to xy. What is the value of x? 3. What is the value of y? Is 1. Is the eigenvector corresponding to eigenvalue when lambda equal to lambda 2 equal to 6. Okay, done. Now I need to represent the model matrix. How to represent the model matrix? Considering the eigenvectors, we are going to represent it in the eigenvalue form. That is, therefore, model matrix is given by P, which is equal to, what is the first eigenvector corresponding to eigenvalue 2? That is 1 minus 1. Next second eigenvector corresponding to the eigenvalue 6 is 3, 1. This is our model matrix. Now I need to find the diagonalization of the given matrix. How to find the diagonalization of the given matrix? That is, diagonalization of the matrix is given by D, which is equal to P inverse AP. Okay, done. What is P? Is the model matrix. What is A? The given matrix. What is P inverse? P inverse, first we need to find. What is P inverse represent? P inverse represent adjoint of P divided by determinant of P. Okay, first let us find adjoint of P. Adjoint of P is given by that is, it is very easy. Consider the P. First let us represent P. First P, which is equal to 1 3 minus 1 1. Now for this P, to find the adjoint of P, it is very easy. Change these diagonal elements. Since the diagonal elements are same, if change also will get the same. Now multiply the negative for these diagonal elements, and minus of minus become plus 1, this becomes minus 3. It is very easy for the 2 cross 2 matrix. Now to find determinant, always you know that determinant of P, that is determinant of 1 3 minus 1 1. Do the determinant of P, which is equal to 1 into 1 minus into minus 1 into 3, that is determinant of P, which is equal to 1 minus into minus plus 3, determinant of P, which is equal to 4, where P inverse, which is equal to 1 by 4 into what is adjoint of P, 1 minus 3 1 1. This is our P inverse. Now considering P inverse AP, now let us find D. That is consider A P. What is P? We have 1 3 minus 1 1. Next, what is P inverse? P inverse, which is equal to 1 by 4 into 1 minus 3 1 1. Okay, now let us find D, which is equal to P inverse AP. Okay, D, which is equal to 1 by 4 into 1 minus 3 1 1 plus A into 5 3 1 3 into what is P, 1 3 minus 1 1. Now let us do this matrix multiplication. First row, first column, D, which is equal to 1 by 4 into 1 minus 3 1 1 into 5 ones are 5, 3 into minus 1 minus 3, 5 threes are 15, 3 into 1 plus 3. Next, 1 3 ones are 1, 3 into minus 1 minus 3, 1 threes are 3, 3 into 1 3. That is D, which is equal to 1 by 4 into 1 minus 3 1 1 into 5 minus 3 2 18 minus 2 6. Now do this matrix multiplication. Now what we are going to get, that is, let us erase this part, that is D. Okay, I need some space. D, which is equal to 1 by 4 into 1 into 2 2, next minus 3 minus into minus plus 3 twos are 6. Done. Now 1 into 18 18 minus 3 into 6 6 threes are minus 18. Next 1 into second row first column, 1 into 2 2, 1 into minus 2 minus 2, 1 into 18 18, 1 into 6 plus 6. Done. Now D, which is equal to 1 by 4 into 2 plus 6 8 0 0, 18 plus 6 24. Now divide 4 for the diagonal elements, that is D equal to 4 8 by 4 2 0, 0, 24 by 4, 6 fours are 24. See, the diagonal elements are 2 and 6. What was our eigenvalues? 2 and 6. Since if you get the same eigenvalues, we call it as the diagonal matrix. Is the diagonal matrix or the diagonalization of the given matrix. This is the one of the most easiest problem. If you know how to find eigenvalues, eigenvectors, by simplifying this simplification, you will understand the diagonal matrix. I hope you have understood this problem. How to simplify? First, consider the matrix, find the characteristic equation. In that characteristic equation, you will get eigenvalues. Corresponding to these eigenvalues, we are going to find eigenvectors with that is lambda 1 equal to 2 and lambda 2 equal to 6. Lambda 2 was the lambda 2 value eigenvector was 1 and minus 1, and eigenvector for the 6 eigenvalue was 6. Corresponding to those eigenvalues have got 3 and 1 eigenvector. Combining these eigenvectors, you have got the model matrix. Represent this model matrix with respect to diagonalization matrix, that is P inverse AP. If you simplify step by step, after finding the simplification, you will get the diagonal matrix. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.